Okay, so there seems to be a little bit of confusion over a few things on the review packet. Some of it is things that we didn't really get much of a chance to talk about as a class because they're from the last video lesson. So for the very top problem, I kind of wanted to go over sort of the different ways of thinking about these problems. It seems like most of the time you guys are comfortable with the ones that are like number 1 and 2, saying MN is to NO as MJ is to JK. That's what's called the triangle proportionality theorem, and it's saying that because these segments are parallel, it cuts the other sides of this triangle into parts that are proportional on the sides. So these segments are in the same ratio. The ones that sometimes students are not as comfortable with initially are ones like number 3, where it says NJ is being compared to OK, and it's wanting to, let me switch colors here, to OK, and it's wanting you to fill in what would correspond with MJ. Well, notice that you're really comparing this little triangle to the medium-sized triangle. You want to think of this as 3 triangles that are sitting on top of each other, with PML being the largest triangle. So if you compare the bottom of the 2 triangles to each other, you'd want to compare the sides of each triangle to each other also. Well, what is the side of the medium triangle? Well, it's MK. So over here, you'd be saying MJ is compared to MK. Okay, that's not really using something new. That's using similar triangles. These triangles are similar because you've got your, always the reflexive, but you've also got the corresponding angles on each side that makes the triangle similar by angle. So in that kind of picture, same thing down here and in the one below that, you want to think of those as being not only one big triangle with a parallel segment in it, but also as little triangles that are stacked on top of each other. Okay, so a couple more of those. For, let's see, number 5, for example, OK is the bottom of a triangle, and so is PL. Well, which triangles are being compared? This time you're comparing the medium triangle to the big triangle. So it's saying if you go bottom of the medium triangle to bottom of the big triangle, and then it's saying your next one should be MO. Well, MO is the side of the medium triangle. You want to use the corresponding side of the big triangle. And what is that? That's MP. Okay, so you're really comparing corresponding parts of the similar triangles. Alright, hopefully that kind of makes sense with the ones that I corrected down here that were not correct. When it says explain your reasoning, I don't care so much that you know the names triangle proportionality theorem and you have used that or when to apply that reason, but I do hope that you're able to determine if those proportions are true or not and correct them if they're not true. A couple of other things I wanted to point out. So this down the the second page. This problem over on the side that I have highlighted to the right. When you're finding y, you're doing something similar to what we were just talking about. So 15 to 39 and 10 to x, that's using similar triangles, right? So 15 to 39 is 2 sides of triangles, and then 10 to x, other two sides of triangles. Now, when you go to do the y's, when you are comparing the parallel segments, 8 and y, those are comparing the bottoms of the little triangle and the bigger triangle. So then if you compare 8 and y, you need to compare a side of the small triangle with a whole side of the big triangle. So you don't want to be using 15 and 24 because 24 is not a side of a triangle. It's a segment on the side. Okay, so be careful in that kind of situation. That actually also, I just remembered, that would have come up in this problem up here as well. So for some of these problems, you're comparing, for example, maybe 3 to 4 and x to 6. That's a triangle proportionality theorem. Because of these parallel segments, it cuts the sides of triangle AFC into proportional segments. However, when you're comparing something like, let's see, when you're comparing to find y, for example, 2 compared to y, you've got to be using similar triangles then. So the bottom of the little triangle to the bottom of the bigger triangle is equal to the side of the little triangle to this side of the bigger, the medium-sized triangle. Okay, so that would be like number 11 over here. 3 is to 2 as 7 is to y. So you want to make sure you're not using the 4. Make sure you're using the 7. Okay. I think there was one other kind of group down here. Yeah. So the ones on the left side, again, these are all from the last video lesson, so I just kind of wanted to emphasize those for you again. This is called the triangle angle bisector theorem. You know to use this when you see a triangle that has an angle bisector in it. So your key here is the fact that those angles are marked to be congruent. So if there's an angle bisector, it will cut the opposite side of this big triangle that we're starting with. It will cut this opposite side into pieces that are proportional to the sides. So you can either do as I did and say, as you follow the red segments there, 8 is to x as 10 is to the part over here, which is 13.5 minus x. Or you could also say 8 is to 10 as x is to 13.5 minus x. Okay, that would be the same equivalent proportion there. So 8 is to 10 as x is to 13.5 minus x. Notice that if you cross multiply that, you'll get the same thing. So these two are equivalent to each other. All right, and then down here, there was a little bit of confusion about kind of how to approach this. When you have parallel lines that are cutting transversals, they will cut the transversals proportionally. So that means that if these are congruent, this is a 1-to-1 ratio. It's going to cut every transversal in the same ratio. So that means these are also 1-to-1, which means they're also congruent to each other. It doesn't mean that these segments are congruent. It means that they're proportional. So you might have these both being 1, but these are both 1.5, for example. So it doesn't mean that the segments there have to all be the same. It just means that the ones with the y's will be the same and the ones with the x's will be the same. That's why you're allowed to solve those equations. Again, something from lesson 7.4. And then similar kind of thing, when you have these parallel lines cut by transversals, it cuts all of the transversals into proportional parts. So since this is 1 to 2, that means this one also has to be 1 to 2. So 1 is to 2 as y is to y plus 3. Or you could say y is to 1 as y plus 3 is to 2. Either of those would work, because again, if you cross multiply, you get 2y equals y plus 3, which is what that one says. And I think that was, the ones down here are sort of similar. There might be other answers for these that I didn't catch. I tried to give you, I noticed that one right there had 2 answers. I tried to give you the ones that I saw had 2. One last thing, the mid-segment. Remember that a mid-segment of a triangle joins midpoints of sides, so those two would be congruent, and those two would be congruent because of the mid-segment. And then 2 facts about the mid-segment. They're parallel. It's parallel to the side of the triangle, and its length is half as long, so that's why I have this proportion set up. However long x is, you'd have to double it to get x plus 7. So you actually could also set this up as x plus 7 is equal to 2 times x. and then subtract the x over 7 equals x. That might be easier, but whichever way you like. And I think that's it for now. Good luck on the test tomorrow.